Whether am I audible to you or not? Please confirm once. Tamalong, can you hear me? Am I audible to you? Hi everyone. I guess in the last class we have completed our previous chapter, which is atoms and molecules. Okay. Uh, we are already have the idea about the atoms and molecules, that how atoms are different from the molecules and what are the properties of atoms and the molecules. Okay. We have done all the discussion in the previous class. Okay. So guys, let's continue. Continue as in let's start with the new chapter, that is structure of atom. It is just like continuation of the atoms. Okay. Till now we have only the overview regarding the atoms, that what actually atom is, what are the subatomic particles. Okay. Now we will check out the atom. Hi, good evening, Itanagar. Welcome. Today we'll check out that how these electron, protons, and neutrons would be appear around the nucleus. Okay. What is the energies associated with them? Means ultimately the structure of the atom, that how atom should look like. What are the theories related to the atoms? Okay. How scientists have contributed in the discovery of the atom while searching the atom. Okay. This was a very big journey actually. Okay. So we will be the part of that journey as well. Okay. We will discuss about those efforts that has been given in the discovery of the atom. Okay. They introduces atom to us. Okay. So guys, let's start with the atom. But before starting with the atom, let's have a recall test. Okay. Just to check out that how much do we know about the atom. Okay. So again, there will be the 5 questions, and you have to attempt all those questions. Just write answers in your notebook, and after that just confirm me once that you have done that, then we'll check out the solutions. Okay. So guys, here we go. Solve these questions. Tamalong, confirm me once. Can you hear me? After attempting this, just inform me once. Hi, good evening, Itanagar. Welcome. Okay. So this good evening is from the second student. Cool. Okay. It's okay. Done, guys? Can we check out the solution section if you have attempted that question? This is something that we have already studied in the previous chapter. Okay, guys, so let's start with the solution section. So this is the solution for this one. Please check out your answer and tell me how many correct you have got. And if you want me to discuss any question among those 5 questions, you are most welcome. Ask me that question. Or if you are having any other doubt, okay, let's say suppose you have got some other question as well, okay, then you may also ask that question, okay. Just confirm me once that how many correct you have got. Oh, how? Oh, sorry. Hi, Shillong, welcome. Only 4. There are only 5. You are having the 4 correct. If you have any doubt, you can please ask me. Question number 5 you want me to discuss. Atoms is indivisible. Oh. False. Yes. Because atom can be subdivided into electron, protons and neutrons. They are not saying that you have to break the atom. Subdivided means atom is the smallest particle. Okay. Means atom cannot contain anything. They want to ask you this one. Okay. So yes, atom is subdivisible into the electron, protons and neutrons. Means atom can further have the parts. We were saying that a matter is something, if we start dividing a matter, we will end up at an atom. Okay. But after researches, after studies, we came to know that no, it is not like that. Or even we can subdivide the atom as well. If we subdivide the atom, we will have the electron, protons and the neutrons. Okay. So guys, finally let's start. Okay, let's start with an activity. They're saying comb rubbed with the dry hairs attracts the paper pieces. First of all, tell me, have you ever done such type of things in your life? That you have rubbed a comb on your hair and the small pieces of the paper are getting attracted towards that comb. Have you done that? Guys, what's happening? Shillong, Itanagar and Tamelong. Guys, are you connected to me? Can I have one person on the system so he or she can reply to me? I have told you I need your replies. Okay. Okay, final Tamelong is back. Tamelong, do you have any internet issues? Okay. Rub a comb on your hair. Now bring the comb close to some paper pieces. Then why were you not replying over there? is supposed to reply. I was asking initially that confirm me once that are you getting me or not. Okay, well, leave it. Now, the question is, what do you think peace? Now, what do you think paper pieces were attracted by the comb? Itanagar is saying something. It is attracted due to the electrostatic energy. Okay, kind of correct answer. What do you think, Shillong and Tamilong? Why so happen? Do you think something about it? There must be some reason, no? Okay, the same activity. You will check out both the solutions at the same time. See, rubber silk cloth. Okay, Itanagar has given the answer. Very good, Itanagar. Rubber silk cloth on the glass rod. Now bring the glass rod close to the inflated balloon. You would observe that glass rod is attracting the silk cloth. Why does this happen? Same reason for both the cases. Let's check out. Yes, combining the hair produces the electric charge. Means initially the glass rod, or we can say the comb, were electrically neutral. Means they were not having any charge. Once you rub with the hair or the silk, cloth of silk, okay, the glass rod and the comb get some charges. Okay. Now what happened? That charge attracts the piece of paper, or we can say the silk cloth. Okay. So that charge is ultimately responsible for that attraction. So what can we say? That electrically charged comb attracts tiny pieces of the paper. The electric charge produced on the comb comes from the atoms present in the comb. Obviously, we have already learned that every matter which we are having till now is made up of atom. Okay. So, comb should also have what? Atoms. So what happened? That the charges from the atoms got transferred from one to another. Okay. Now, just because of that development of the charges, it starts attracting and repelling the other substances. Okay. This shows that some charged particles are present on the atom of the comb. Similarly, glass rod gets an electric charge and attracts silk cloth. Okay. So this is nothing but, guys, these two phenomena are representing that every matter is made up of the atom, and every atom has a charge. Just because rubbing with each other, they got the energy, and that charge, by having the energy, by gaining the energy, get transferred from one substance to another substance and makes the neutral substance to a charged particle. Okay. So, excuse me. So, this is ultimately just to showing that the charges are actually present. Okay. First of all, confirm me, guys, are you clear with the solutions of the first two activities? Are you having any doubt or question for me? If yes, you can please ask me. If not, then just confirm me so that we can proceed. Itanagar, Tamalong, Shillong, guys, do you have any doubt? Yes. Previous chapter was completed. Now the question is, where does the charged particle come from? Okay. See, matter is made up of tiny particles called the atoms, and these experiments are nothing but indicating that the atoms have the charges. Okay, so atoms are made up of three subatomic particles, or we can say the fundamental particles called as electrons, protons, and the neutrons. Okay, so charges are already been present on the atoms. Okay, and they just get transferred on each other. Okay, please copy this one, copy and then confirm. That is structure of atom. Okay, guys, have you copied that? Can we proceed? Okay, take your time, copy this one. Copy and then confirm. Okay, a question for you. Read the question, attempt it. We studied about the matter and the presence of charges on it. Out of the given options, which one would be the correct representation of a matter? Circle is representing the atom. Positive means positive charge and negative means the negative charge. Okay, just check out the options A, B, C. Then say what can be the correct arrangement. Okay, Tamalong has given the answer. Itanagar also. Let's check out option C, which is option down to the A. Obviously, atom contains the positive and the negative charge, na? So positive and negative should be present inside the circle. Okay, that's why option C would be the correct answer. So let's move on, guys. Types of subatomic particles. See, we can have the three subatomic particles, which are the fundamental particles: electron, proton, and the neutron. These are the new representations of the electron, proton, and the neutron. Guys, this is the data that you have to remember, that what is the mass of electron. It is about 9.1 in 10 to the power minus 28. Yes, that is in grams, na? Okay, fine. Minus 28 grams. Proton is 1.6 into 10 to the power minus 24 grams. Neutron is also having the same mass. Relative mass. I hope so. You have knowledge about the relative mass. Okay. Absolute charge is minus 1.6 and 10 to the power minus 19 coulombs. C stands for the coulombs, guys, which is a unit of charge. Proton and electron having the same magnitude of the charge, only the difference in the charges. Okay, signs. Electron having the negative charge, proton having the positive charge. Neutron does not carry any charge. Okay, so relative charge is nothing but what? Minus 1 and the plus 1. Okay. There is a note as well that proton and neutrons are almost having the same mass, as you can see in the table as well. But mass of the proton is about 2000 times as that of the electron. It is 2000 times heavier as you compared with the electron. Okay, please copy this one. Guys, if you're having any out of the box question that you want to ask me based on this one, or you're thinking that why is this happening and what happened if I think about this one, you can please ask me. And after just copying that, confirm me once. Once copied, please confirm me once. Guys, have you copied that? Okay, dear, I'm waiting. Okay, let's move on. Now, the discovery of the subatomic particles. Okay. So, let's start with the electron. Okay. So, the person who discovered the electron it's okay, Itanagar, was J.J. Thomson. Okay. What actually happened? That he taken a gas inside a discharge tube. Discharge tube means the setup where you have filled that gas. Okay, at very low pressure. Okay, why? The question is why we are having the low pressure. Just because when you apply the potential across it, so the atom of the gas just get collide with each other and get ionized. Okay, so once they get ionized, they observed that there is something sparks present are appeared on the anode side. See, there is one more thing on the anode side. Let me show you something. Give me a minute. See, let me show you something. This was the setup. Yeah, I have just started it. Don't worry. Okay, this is just for understanding. You can copy the diagram from the, we can see the slide. Just understand this. See, this is your negative part. This is your positive part. This is the battery. Okay, inside this gas is present like this, and here there is a fluorescent coating. Okay, and this plate is perforated actually. Perforate means having some small, we can say the spaces between them. Okay. Now, what happened? Let's suppose this is the gas A. Okay. This is gas A. When you apply potential, so what happened? It get ionized and loses an electron. See, because now we know that, that's why I'm making you understand that this is how electron will appeared over there. Okay, but the question is how scientists have observed that these are the electrons only. See, scientists know only one thing, that when gas gets ionized, it is emitting something. Don't know what. Okay, so they have observed that there are some bright flashes have been produced on the anode side. This is the anode part, and this is your cathode part. This is your cathode part. Okay. This coating is just because this coating has been done just to observe that what is striking over there. Okay, just to confirm, because we know that we cannot see the electrons. Okay, but we can just observe whenever they strike on this coating, there is a bright flashes will be produced over there. Okay. So scientists were observing that there's something is striking on this anode part. Okay, so they actually start thinking about it, and they said that, see, there is a negative charge. Okay, and this is attracting towards the positive plate. We know that the unlike charges attract each other and like charges repel each other. So what happened? That these are the electrons which are moving actually in this direction. Why? Because there is a repulsion between this electrode and this electron. Okay. Now, after getting passed through this plate, they get extracted over there. Okay, so just after this experiment, Thomson has confirmed that electron contains the particles. Name was still not given. They were using the term particle. That atoms are having some particles. Okay, and the charge on that particle is negative. Okay, discharge tube. Okay, and those particles are having what? Negative charge. Why they are having the negative charge? Because it is moving away from the negative electrode, just because of repulsion between them. Okay. Later on, a scientist name is Stoney, not Tony, Stoney. Stoney has given the name electron. Okay, and the discovery was done by what? J.J. Thomson. Okay, so this is how the discovery of electrons has been made. Now, please confirm me once. Are you clear that how electrons has been discovered? Please confirm me once so that you can start copying that. I'll shift to the slide. Confirm me once, guys. Itanagar, Tamelong, Shillong. You guys are looking a little bit lazy today. Will you say something? No, atoms are not pressurized. Low pressure means very less number of gaseous atoms. Okay. Actually, look at this battery. Look at this battery. This battery is actually supplying the energy. We can say the potential. Okay. That potential is actually responsible for the emission of that electron. Okay. See, electron is coming out of the atom. Obviously, you need to supply some energy to just get electron out of atom. So this potential is doing what? Means this battery is doing what? Is giving that energy to just get out the electron. Okay. Guys, will you confirm once, Itanagar, Tamelong and Shillong? Are you clear with this one? Why A plus and because the net charge on the atom is 0. See, there is a negative charge and there is a positive charge. Means it is like -1 and it is like +1. 1 second. It is like +1, it is like -1. Okay, so minus plus will become what? 0. Yes, inside the container, which is a discharge tube, there is a gas particles. Tamelong, are you clear with the doubt? Okay. So, 1 second. So look at this. In the experiment, gas at a low pressure was taken inside the discharge tube made of glass. At the ends of the discharge tube, 2 electrodes were placed connected to a battery for a high voltage supply. The electrodes connected to the negative and positive end known as the cathode and the positive as anode. Okay. Then he then observed a stream of negatively charged particles coming out of the cathode towards the anode. These particles were called the electrons. Okay, the collection of the negatively charged particle emitted from the cathode of the discharge tube is called the cathode rays. Okay, and this one is the setup. Okay, please copy this. Please copy and then confirm that you have copied that. Please copy and then confirm. It's okay, Tanago. Okay. Guys, for the diagram, I'll suggest you please add this one as well. Okay. Please add this one as well. This is the fluorescent coating, or you can say the ZNS screen or fluorescent screen. Okay, Tamilong. See, I was just saying that inside the tube we have filled up gas A. Okay. Fluorescent coating, it is just used to detect the presence of the ions. Means whenever a charged particle strikes over it, it produces a bright flash. Okay. Okay. First of all, copy this one, guys. Copy this one. As in, just added this one on the anode part. Just make that uh, shaded region and represents that is a fluorescent screen. Okay, so I'm explaining it again, guys. Let me tell you something. See, inside this, right now only the gas particles. Any type of gas you can take, any type of gas, okay? It has to only emit the electrons, okay? Like hydrogen, chlorine. Oh, chlorine wouldn't release the electron actually, okay? You can take another one, okay? Just check out. Only initially, guys, look at this. We have only A gas, means A, name of the gas, okay? Now, when you apply the potential across it, this gas get ionized, means this gas get converted into the ions, which look like this. A positive, E minus, okay, representing the charges, okay? See, we do not know what is happening over there. So we have just perforate the anode part and placed a ZNS screen, or we can say the fluorescent screen. So what happened? That this electron, see, let's suppose this is the electron. This electron is moving in this direction, and after coming out of this anode electrode, it strikes over that reddish screen. Okay, so whenever it strikes over that reddish screen, it produces a bright flash. Okay, so the point was scientists do not know this is the electron, but yes, scientists has confirmed one thing, that the atoms are not actually neutral. Means they are having some charges, and that charges can be taken out from that atom. Okay, so whenever you supply the energy, the electron takes up that energy and gets out of the atom. Okay, see, look at this. This is the electron. This was present inside this one, but now it is what? Out of the atom. Okay, now because it contains the negative charge, that's why it is moving towards the positive plate, and it is moving away from the negative plate. Are you getting this? So this is how you have discovered the electron. Okay, and this was nothing but the discovery of proton as well. Okay, first of all, tell me, are you clear with the electron? Confirm me once. Everyone, please confirm me once. Are you clear with this one? Them along. Okay, now this is the proton. Proton means having the positive charge. Okay, so what scientists have done this time? No, A represents the atom, gaseous atom, but A plus is representing the gaseous ion, which is known as the proton. Okay, let's say suppose I take an example that hydrogen gas on ionizing give you H plus and electron. This is the electron and this is the proton. Now question is how we can discover the proton. So the another scientist have performed the same experiment. Okay, but this time he did something else. This time he make this a complete electrode and perforate cathode this time. Perforated cathode this time and place the ZNS screen, means zinc coating, ZNS coating on the cathode part. See, just because this is having the positive charge, look at this, I'm talking about this one. Just because this is having the positive charge, it will move away from the positive electrode and it will move towards the negative electrode. So what happened? That it starts striking here. This is your A positive. That it starts striking here. So obviously this time it will produce a flash over this side. Okay, this confirmed that atom is not only having the electron, it has the proton as well. Proton means something which can act as a positive charge. Okay, so this is how the discovery of protons has been made. Tell me, are you clear with the discovery of proton? Itanagar, Tamalong, and the Shillong Center. In this, just cathode was perforated. And again, same coating, but a charged particle is striking over there. That's why it produces the flash, and that makes it as a what? Positively charged. Something which is positively charged. Itanagar, Tamalong, are you clear? Okay, then Itanagar is saying yes. Tamalong and Shillong, guys, what do you think? I mean, are you clear with this one? If not, you can please ask me. So this is the proton discovery by the Goldstein. Okay, please copy this one. Goldstein observed the same experiment with the different situation, that the anode emitted positive particle which were called proton, canal rays as well. Okay, please copy this one. Yes, copy the neutrons as well. You need to remember that there is something also there which is neutrally charged particles were discovered by the James Chadwick. Okay, neutrons are present in all atoms except the hydrogen. Okay, the detailed discovery is not right now in your syllabus. Okay, of the neutrons. So just copy this and confirm me once. copy and then confirm, guys. So after the discovery of the subatomic particles, which were the electron, protons, and the neutrons, now scientists are actually facing a new challenge. Or the challenge was that how these subatomic particles should be present inside the atom. Means what should be their positions, what should be their energies, how should they behave inside the atom. Okay. Before that, they all were thinking that the atom is spherical in nature. That was quite true actually. Okay. That the atom is spherical. Now the question is, in that sphere, how we can get these type of particles. Okay. Like electrons, protons, and the neutrons. Okay. So the one of the first attempt we can say, not only the this is not we can say the first attempt, but yes, that this is the attempt that actually got highlighted. Okay. Yes, this was unsuccessful, but yes, this was a time where we actually start thinking about the atom. Okay. So Thomson was a scientist who actually relate atom with the watermelon. Okay. He simply said that the atom is like a watermelon. Okay. As we can see that watermelon having the reddish part and that greenish part of the outer layer, that all are what? Positive charge. Okay. And those seeds which are actually present, these seeds are nothing but what? Electrons. Okay. So actually he was able to prove a point that atom was electrically neutral. See, just to be electrically neutral, there must be the positive as well as negative charge. Okay. Means equal positive and the negative charge. So he eventually proved that the total positive charge means the other part of the watermelon other than the seeds are positively charged, and the seeds are nothing but what? Electrons. Okay. Which gets embedded into the watermelon. Just because I'm relating with the watermelon. Okay. Also known as what? Plum pudding Thomson model of atom. Okay. So he simply recognized atom as a sphere which is having the positive charge, and inside that positive charge there are electrons present over there. Okay. So there is a combination of the positive and negative charge and making the atom electrically neutral. Okay. So this was the attempt. So let's check out. It is also known as the Thomson's plum pudding model. In 1903, J.J. Thomson proposed the structure of an atom similar to that of a Christmas pudding. Okay. He proposed that an atom is positively charged sphere and the electrons are embedded in it. Okay. The magnitude of the positive and negative charge is same inside the atom, so net charge inside the atom is 0. Means he proved a very good point actually, atom is electrically neutral. Because after that all the study was oriented on a particular point that we have to prove a point that atom is electrically neutral. Okay. And for this purpose, many scientists has given the attempt, and finally we are having a very good things regarding the atom. Means very correct information. So Thomson model of atom, that J.J. Thomson used the cathode ray tubes to demonstrate the cathode ray respond to both magnetic and electric field. Since ray was attracted to the positive electric plate. Okay, 1 second, guys. Yes. Since rays were attracted to the positive electric field plate over the cathode ray tube, he determined that the ray must be composed of the negatively charged part. Means he was just confirming that the positive and the negative part. Means electron carries the negative charge and the rest part contains the positive charge. Okay. So this is the limitation. Just going before the limitation, just copy this one. And if you have any doubt, please ask me. If not, then please go. Then please copy it and confirm me. Guys, please copy and then confirm. Okay, copy this one as well. Yes, dear, you're supposed to draw the diagram as well. That is very important. Please draw this one. Okay. Okay, Tamalong. Please draw the diagram as well. Over now? Okay. Limitations. Means after just confirming the electrons and the protons inside the atom, means it has proved that atom is electrically neutral. But even after proving that point, there is certain points which couldn't be proved by the Thomson. The first was it couldn't explain the stability of an atom. That is how positive charge in an atom holds a negatively charged electron. Obviously, between the positive and the negative charge, there is an electrostatic force of attraction. Okay, so it was not confirming that how many positive charge would be there, how they are attracting the other electrons. If electrons might be present or with near to each other, so they must repel each other. That causes the instability. Okay, so lots of points were there regarding the stability of the atom, which couldn't be proved by the Thomson. Okay, one of the strongest drawbacks by which this model got failed over there. Okay, it couldn't explain the position of the nucleus in an atom. Nucleus means a place of where the mass and the positive charge would be there inside the atom. Okay, so he couldn't actually define, or we can say the able to propose that of where we can place the nucleus. Okay, what should be the position inside the sphere? Sphere means the atom. It couldn't explain the scattering of the alpha particle. Scattering of alpha particle, guys, it is actually done after the failure of the first 2 points. Means Thomson model just got failed after the first 2 points. Then Rutherford has performed his own experiment. Just keep in mind, means ultimately he was testing the Thomson's model, that how much correct it was. Okay, according to Thomson, that positive charge means atom is a positively charged sphere. Means atom carries the positive charge over it. Inside it, we have got what? Electrons. As well as positive charge is also inside as well. Okay. So obviously, whenever a positive charge get in contact with that positive charge, it must repel each other. Okay. So Rutherford has performed that experiment, but unfortunately, Thomson's model couldn't prove his points correct, and Rutherford has got a new hike. New hike as in that Rutherford got highlighted that that model was not too correct actually. Okay. So alpha scattering experiment, this is a new one which has been performed by the Rutherford. Okay. Please copy these 3 points, and if you are having any doubt, you can please ask me. Okay. I have to discuss the Rutherford atomic model as well. Okay. But before that, please copy this one. Copy and then confirm. Okay, the last page. Please copy. Copy and then confirm. This one is done. Are you asking about this one? The page after this was this one, dear. This is the page. Okay, copy now. Done? Okay. Okay, let's move on. This is the question for you guys. Attempt this question. Tell me your answer. What do you think about it? Okay, Itanagar has given the answer. Okay, Itanagar. Either it should be B or C, according to you, na? So just opt one. Okay, so let's check out the answer. C. I guess so we have already covered it. Obviously, he knows that electron exists, but no idea about the existence of the protons. Means we were discussing about it. He cannot confirm the presence of nucleus. Nucleus means something which contains the protons. Getting it? If you are having the doubt, you can please ask me. Otherwise, we can move on. So, this is all about the first slide. Okay. So, I guess so we have covered this topic. So, let's have a recall test first of the next section. Let's move on, guys. Okay. So, again, there's a 5 questions for you guys. Attempt all these questions. After attempting these 3 questions, just let me know so that I'll shift it to the next slide. Okay, Tanago. Let's move on to the next two questions. Attempt, please, so that we will check out the solution. Done? Question number 3. Tamelong, first attempt 4 and 5, then I'll shift you to the previous slide. First of all, attempt this one, then I'll move on to the previous slide. Okay, Tanago. Okay. Check out the question number 3, please. Okay. So these are the answers, guys. Check out the answers and please tell me of which question is your doubt. And please share your correct answers as well. Okay, Tanagar, it's okay. If you want me to discuss any question, you can please ask me. All clear? Tamelong, Itanagar and Shillong? Please tell me once. Congratulations, Itanagar. What do you say, Tamelong? How much correct answers you have got? Wow. I guess only 5 questions were there. So you should get the 5. Good. I got surprised if you say the 6. But unfortunately, you haven't surprised me. Cool. Please carry on. That's 5 out of 5. Okay, great. Great work, guys. Let's move on. There's the alpha ray Scattering experiment, guys, I don't think so that that can be covered. I'll suggest please do one thing. Okay, let's cover it in the next class. But yes, you're having doubts, you can please ask me. Whatever doubts you want to ask me. If you're having the doubts, you can please ask me your doubts. If not, then I'll suggest please do copy that Rutherford scattering experiment, and I'll tell you about the scattering experiment later on. Tell me quickly what you want to do. Okay, so let's copy that first. Okay. Check out the, please write the heading Rutherford alpha particle scattering experiment. As you're very fast as well, so I guess so we can start writing right now. Please start writing. Make a heading. Please copy this one. After copying that, just confirm me once. No, no, no. Oh, this is the atomic model. This is not the discovery of neutron, dear. We have started with the atomic model. So first attempt was given by the Thomson, and Rutherford was just trying to prove Thomson's point. But unfortunately he get a new things. Okay. Not unfortunately, but yes, unfortunate for the Thomson. Copied, guys? If you have copied, please inform me once so that I'll shift it to the next slide. Okay, Tamelong, have you done that? Dear alpha, beta, and gamma are the rays. Means they have emitted from the radioactive substances. Okay, radioactive substances are those substances which have disintegration. Disintegration means they degrade their own without any external help. Okay, and emits the alpha, beta, and gamma rays. Okay, quite harmful as well. Okay, so whenever we need to deal with the radioactive substances, we have to be very careful. Okay, I hope so. You have heard about a name of Madame Curie, if you have heard about that name. Okay, because she was studying the radium. Okay, so even she has got uh, passed away as well, just because of, no, you haven't heard about it? Madame Curie was the scientist actually. She was the scientist. She was studying the radioactive substances and she was studying the radium. Even she has got the Nobel Prize for the study of the radium as well. Okay. Radium is a radioactive substance which emits alpha, beta, and gamma rays. Okay. What was the point actually? What I was trying to say, that these are very harmful actually. Okay. Even the clothes or whatever the belongings which is still present to us of Madame Curie are still infected by the these waves. We can say these rays. Okay, they are still infected. So you can even imagine that how harmful these are. Okay, so alpha, beta, and gamma rays are rays, nothing else. Okay, have you seen the Hulk? How many of you have seen the Hulk? Do you know something about the Hulk? Yes. So I hope so. If you have seen the Hulk, sorry, if you have seen the Hulk, there is a point, not a point. We can say, yeah, actually, in the movie they used to say the gamma rays, means gamma rays got striked over a person, and that person get converted into a beast. Okay, means a giant actually, which has enormous powers. Okay, so actually, if you see that, you will observe that they were repeatedly saying that gamma rays are very harmful, means they have very high penetration power, means they can penetrate through a wall as well. Okay, so after the striking of the gamma rays on a person, it must get penetrated and just finished up that person. But no, that person is converted into a beast. But means that was just a fiction actually. That's the creation of the character. Okay, but I'm just relating that the gamma rays are very harmful actually, if you observe that particular movie. Okay, penetrate means to just get through or something. That is a penetration. Okay. So gamma rays, even all the rays are harmful. Even gamma is very, very harmful. They have the very high penetration power. Okay. So Rutherford has performed that experiment. Even he has got the Nobel Prize as well for the discovery of the nucleus. Nucleus about which we have no information by the time of the Thomson, means when Thomson has discovered his model. Okay. So we will have a detailed discussion over the discovery of the nucleus that was given by the Rutherford. Okay. Yeah, you can say it, Anaga. Okay. So guys, let's wind up today's session. Okay. Lots of interesting things are over there to study. Okay. So we will move on about the we will move on from the Thomson to the Rutherford in the next class. Thomson is over. Okay. So now let's have a new model. Means let's have a new discoveries about the atom. Okay, guys. So thank you so much, guys. Let's wind up today's session. I'll see you next time. Till then, take care. Bye bye. Have a good time. Stay healthy, please. Take care of yourself. Good night.